Hello students, welcome to the first video of this new playlist. So in this playlist, I'll upload solution videos for each of the question of the most recent past paper of Statistics 1, which is the October 2024 S1 paper. So this paper has total of 8 questions. So under this playlist you will find total of 8 videos where I'll try to explain each of the question as much as in detail as possible. So since this is the first video of the playlist, so in this video we will be solving the first question of the October 2024 Statistics 1 paper. So let's see what's the first question of this most recent paper is about. So you can see the first question on the screen. So let's get started with question number 1. Okay, here the question says the back-to-back stem and leaf diagram on page 3 shows information about the running times of 31 action films and 31 what? Comedy films. Okay, so the back-to-back stem leaf diagram. Here you see on the second page the back-to-back stem leaf diagram has been given. So the left side, on the left side the leaf, on the left side it shows the action films, the running times for action films, and on the right leaf the it shows the running times for the comedy films. Okay, and at the middle it's the stem, right? Okay, so the key it's given there, like how you can interpret this stem leaf diagram. Okay, fine. So the running times are given to the nearest minutes. So the in the stem leaf diagram the running times you can see it's given to the nearest what? Minutes. Fine. So the first part, that is part A, it's asking here to write down the model running time for these action films. Okay, so specific, they have specified for action films. Okay, so the mode of the running time for the action films. Okay, so what is mode? Which data is considered as the mode? The data which occurs the most frequently, right? This is the mode. So let's see from the back-to-back stem leaf diagram for the action films. Okay, uh, which data, which running time occurs the most? Have a look here. 129. Nope. Okay, we can see that 137, it's repeating thrice, and none of the other data values are repeating thrice. Okay, so we can say that 137 is the what? Model running time. Okay, so for part A the answer would be 137 what? Minutes. This is the what? Model running time, and that's what part A has asked for. Fine. Next is part B. Okay, in part B the question says some of the quartiles for these two distributions are shown in the table below. Okay, fine. So this table shows the what? The quartiles for the running time of action films and the running time of the comedy films. Okay, so action films, comedy films, what? It's lower quartile for action films is 121. For comedy films it's what? A. For median for action films it's B, and for comedy films it is what? 117. Okay, and for upper quartile for the action films that is Q3, 138, and Q3 for comedy films it's what? C. Fine. Okay, so part B is asking here to find the value of A, that is the Q1 of comedy films, the value of B, that is the Q2 of action films, and the value of C, that is Q3 for the what? Comedy films. Okay, so that means we need to find out the what? Quartiles. Okay, fine. So at first consider A. A is the lower quartile, Q1 for the comedy films. Okay, so we know that what? Q1. Okay, A is the, okay, it is discrete data, isn't it? Because the data values are individually specified, right? So that means for discrete data, we know that Q1 is what? Q1 is the n over what? N over fourth term. Okay, n over fourth term, we can put it 31. The total number of data is 31. 31 over fourth term, we can write it as what? Since it will give decimal value, so 31 over 4, it gives what? 7.75. Okay, so 31 th, which is what? 7.75 th. We can what? Should we round up or round down? Always for decimal values we round up for finding quartiles or percentiles, isn't it? So 8 term for discrete data, 8 term. So for action films, okay, it's for action films or comedy. Okay, for comedy films we need to get the 8th term. Okay, so let's have a look on the stem leaf diagram. 8th term for comedy films, this is 5, 6, 7, 8. So this is 106, right? So A is 106. Okay, next is B. So B is the what? Isn't it the median? Okay, median. So this is n over 2, isn't it? So 13 over 2 th, which is basically 15.5 th. That is what? The 16th term. Okay, so B would be what? 16th term for action films. Okay, so this is 1, 6 and 16, 10. This is what? 129, right? So B equals to what? 129. Done. Okay, next is what? The value of C. Okay, so C is the what? Upper quartile, isn't it? Q3. So Q3, for Q3, what's the formula? C is the what? 3n over 4, right? So 3 times 31 over 4, that is basically 93 over 4, which will give you 23.25. 23.25 th, which should be rounded up. So 24th term for action films, isn't it? Isn't it C for action films, if I'm not wrong? No, it's for comedy forms. Okay, so C equals to what? We have to see the 24th term for comedy films. Okay, so 5, 6, 11, 8 is 19. So 19 plus what? 19, 20, 21, 22, 23, 24, which is 126. So 126. This is the value for C. So we got the value for C 126, the value for B is 129, and the value for A is what? 106. And that's what part B has asked for. Fine. Okay, next is part C. In part C, the question says, for these action films, find to one decimal place. Okay, part C1. In part 1, they are asking to find the mean running time. Okay, the mean. For the action films, they have specified for action films, we need to find out the mean running time. Okay, so mean running time is what? Sum of x, that is sum of all the data over the time. So you can see here, you may use sum of x equals to 4016, and yeah, sum of x squared is 525056, where x is the running time in minutes of an action film. Okay, for the action films, the sum of all the data is given already. Okay, so they have made it easy for us. Okay, so for part C1, we need to find out the mean, which is x bar. X bar is what? Sum of x over n. So 4016 over n is what? 31. So that would be what? 4016 over 31. Okay, so 4016 over 31, it gives you 129.54 something. 129.548 something. Okay, so what we got? Mean what? Running time for action films is what? x bar, it is what we should round to 1 decimal place, right? 1 decimal place, yeah. So that would be 129.5 minutes. That's it. That's the answer for part C. What? C1. Fine. Next is part C2. In part C2, they are asking to find to 1 decimal place for the action films the standard deviation of the running time. So standard deviation, we need to find out the standard deviation. We know that standard deviation is what? Square root of the variance. Okay, so the formula for standard deviation, it's what? For part C2, standard deviation is sigma, right? Sigma is equals to square root of sum of x squared. So sum of x squared is 525,056. Okay, 525,056. Okay, so 525,056 over sum of x squared over n. N is how much? N is 31, right? Minus the mean. Mean is what? 4016 over 31, right? So sum of x squared over n minus the mean squared. This is the standard deviation. So let's calculate 525,056 over 31 minus the mean squared. Mean is 4016 over 31 what? Whole squared. So then square root of answer, that would give you 12.430 something. Okay, so what we got? The standard deviation to 1 decimal place. The standard deviation for running time of action films, right? Action films is what? Sigma equals to equivalent. We are rounding it to how many decimal place? 1 decimal place. 12.4 minutes. That's it. So that's what part C2 has asked for. Fine. Okay, next is part D. So in part D, the question says one measure of skewness is found using mean minus mode over the standard deviation. Okay, so part D is asking here to evaluate this measure and describe the skewness for the running time of these action films. Okay, so we need to find out the measure of skewness, right, for the action films, for the running times, the data of running times of the action films. Okay, fine. So what is basically skewness represents? Skewness basically represents the asymmetry of the distribution, right? So asymmetry means basically from being what symmetrically distributed, how much it is getting deviated from being what symmetrically distributed. So for this data, for action films, we have to find out using this formula what the skewness, that is like how much it is getting deviated from being distributed symmetrically. Okay, okay, so how to measure this? The formula is already given, so just plug in the values, mean, mode, standard deviation. We will get the measure for skewness. Okay, okay, so for part D, skewness is what? They said mean minus mode. Okay, mean is how much? Mean we got 4016 over what? 31 minus mode. Mode, what we got? Mode in part A, we wrote the mode. What was that? It was 129 if I'm not wrong. 137, sorry, 137 is the mode. Okay, so minus 137. Is it 137? Is it? Okay, 137 exactly. Okay, 137 over standard deviation. The standard deviation we got 12 point, the exact value was 12.4 3003311. Okay, so the measure of skewness, let's calculate. 4016/31 minus 137, divide the answer. It was the previous answer was saved in my calculator, so we got negative 0.599. okay, this is the measure of skewness that we got. Okay, so based on that, we need to say what type of skewness is this. It's what? It's less than 0. Okay, so we can make a deduction here that so the distribution have what? Negative skewness. That's it. Negative skewness means asymmetrical. Let me explain a bit about it. A symmetrical distribution is like this. Symmetrical, this is symmetrical. The mean is right at the middle, mode is right at the middle, the median is definitely at the middle. Okay, so since it has negative skewness, that means what? It will be if this is the middle, okay, it will be more distributed there like this. Okay, so the mode will be on the left, on that side the mode would be, and mean would be on that side. Okay, since it is negative skewness, that's why it is negative skewness, because the most of the data are on the left of the what? Midpoint. That's why it is negative skewness. If the what? Skewness was positive, then it would be what? Like this. Okay, most of the data would be on the right side of the median. Okay, and so we got the skewness, that is what? The action films, the running times of action films, it's what? Negatively it has what? Negative skewness, and that's what part D has asked for. Fine. Okay, next is part E. In part E, the question is asking to comment on one difference between the distribution of the running times of these action films and the distribution of the running times of these what? Comedy films. State the values of any statistics you have used to support your comment. Okay, so we need to give what? A comment on the difference between the distributions of the two data set of data. Okay, so for commenting on what? Difference between the two data, what we do actually, we focus on the measure of spread of the two data and the what? Measure of location of the two data, right? But since this question is only for 1 mark, so that means we need to only comment on the measure of what? Location. So in that case, we can comment on mean, mode, median, right? So only for 1 mark we will comment on what? The median, because median is perfect in this case, because both the median for both of the set of data is known to us, and it is more it will give us more perfect what? Idea about the distribution of the two data values, right? And yeah, so let's consider the median of the two data values. For the median of action films, we got 129. Okay, and for comedy films, it's what? 117. So definitely we can see what? Median for action films is what? Greater than the median of comedy films. That's what we can tell about the difference in the distribution, isn't it? Right? So that's what we will just write it down here. Okay, so median running times of what? Action films is greater than what? It's greater than that of comedy films, right? That's it. That's what we got the difference. Now they said you need to state the values. Okay, films as what? 129, it's greater than what? 117. Okay, that's it. And that's the difference we can what? Tell here about the distribution of the two what? Set of data. And that's what part E has asked for. And that's the end of the first question from the October 2024 S1 paper. Fine.